and will continue to be solving literal equations for a designated variable. And again, we're going to work on this for days. I'm going to write, even though you have some official notes over this already, I'm just going to write a few reminders here at the top of the paper. I'd like you to go ahead and copy down problem number 1. And we are going to attempt to solve this literal equation. Remember, a literal equation is just the big kid word for an equation that's got a whole bunch of variables in it. At least 2, usually more though. And solving it for a designated variable means that we're just literally going to rearrange it to get whatever the designated variable is isolated. So in this particular case, it says to solve for x. So this is our designated variable because it's asking us to rearrange the formula so that x is by itself. And the 2 big ideas that we didn't really discuss them, I just told you about them in class on Friday, is that you're going to isolate the variable exactly the same way that you always do. Okay, so you are going to isolate the variable by using inverse operations. Remember, inverse is the fancy word for opposite. So you're going to use inverse operations. And you've got to use your properties of equality, which remember just means what I do to one side, I have to do to the other side. So you're not doing anything that you don't deep down already know how to do. It's just messing with your head and making things a little bit jiggity for you because it's got all these variables, this alphabet soup, instead of a lot of numbers in there. So that's kind of what's messing with you guys a little bit. So we're going to look at example number 1. If you haven't already copied it down into your notebook, please do. I'm going to recopy it down here because I hate how this worksheet prints where it like squishes the directions and the problem number all together. So I'm just recopying it. So remember, because I'm a visual person, I like to go in and highlight what it is exactly that I'm solving for. That tells me I need to get rid of all the other crap that's hanging out there with it so that I can get this variable by itself. So here's where I'm going to ask you my first question, and you can either type it in the chat or you can put your answer on the whiteboard. Either one is okay, but I want an answer from you. I don't want you to say IDK or anything. It doesn't matter if your answer is wrong, okay? You're going to learn by messing up. And to be honest, you're going to mess up a lot the next few days, and that's going to be okay because you're going to get smarter. So my question for you is, the x is not isolated. There's something over there with it. So my question that I want you to put on your board is, what is it exactly that we have to eliminate? What do we have to get rid of? What is hanging out there with the x that needs to go? And just as important as telling me the letter or letters that we're going to have to get rid of, I also want you to tell me what operation is currently there. Like, what's the operation that we need to cancel out? That should always be primary on your mind. Like, this is a really crappy thought bubble, okay? What do you need to eliminate? Like, what is there that needs to go? I'm going to give you a minute to either type it into the chat or put it on your whiteboard. It does not matter if you're wrong. Doesn't matter. Doesn't matter. All right, I see a lot of people saying M, and I agree with that. Now tell me specifically what operation, what is being done with that M in the original problem. What is that operation? We're right, the M is over there with the X. It's got to go. Are we in the original problem? Are we multiplying, dividing, adding, subtracting? What is happening with that M? Either put it in the chat, or if you don't feel comfortable doing that, you can put it on the whiteboard. That's what it's there for. Either one, I'm looking at them both. I see a bunch of people saying it correctly. You're right. That is division. The original problem is division. So now my next question for you is, how the heck are we going to cancel out dividing by m? Our very first step. What is the inverse of dividing by m? What is the inverse of that? I'll wait a second for you guys to type it. Oh, yay! We're getting it. We're getting it. Exactly. I'm going to give everybody just another minute. I'm looking at the slides too. Perfect. Yes. So we already have division. So you have to think to yourself, okay, what the heck is hanging out there with the variable that needs to go? And more importantly, how am I going to get rid of it? And you guys have correctly identified the fact that we are going to cancel. So oops, let me write that in pink. So we are going to cancel dividing. I'm going to use the baby division sign just this once because I know we all know what that means, and I'm trying to do like shorthand. So I'm going to cancel dividing by m by multiplying. What does it look like to multiply by m? It looks exactly the same as it does if you multiply both sides by 2 or 8 or whatever. So how am I going to cancel out dividing by m? I'm going to multiply. So we did our inverse operation. Now I need to remember my other big ideas. I still have to keep in mind my properties of equality. Since I multiplied the left-hand side by m, I have to multiply the right side by m. So over on the left, those m's have now canceled each other out. And I have my x isolated. I have solved for x exactly like the problem asks me to do. And we did that by doing inverse operations and by looking at our properties of equality. Now, here is something that people have a tendency to do wrong. Remember, wrong is red. So keep that in mind. So I've got P times M, and then a lot of people think, now that part's correct. A lot of people think that they need to multiply the M times the N as well, but you do not. When you are multiplying by any number, really, it's really, when you're multiplying it by like a fraction, it's really the same thing as multiplying by M over 1. So when we go through and multiply it together, all you really need to do is the P times M, which is PM, and then N times 1, which is still just an N. So sometimes it looks like a big, nasty, equation with fractions, but it's really only takes one step to cancel it. So this is a perfect example of one where look and see what's happening with that variable and then do the opposite. So I'm going to pause here for a second, check my text, check my remind, check the chat. Do we feel okay? Is there anything I need to clarify about this one? All right, you guys try one that's very similar. Right here. So number 2 that I have up there. I'm going to kind of leave number 1 in there so that in case you haven't gotten a chance to write it down yet, you got it. Number 2 is very similar. I'm going to shut up for just a second. Give y'all a moment to try it. I know that the touch screen on the whiteboard is a little bit hard for some of you guys if you want to use a text box, but I'd really like to see what you get for your answer when you've gotten this finished. Messy, we can deal with messy. I don't care. I just want to see your thinking.
My whiteboard keeps disconnecting me.
Oh, okay. If you just want, that's all right. I'll just have, that's kind of weird that that's doing that, but it's all right. Thanks for telling me so that I know you're not just ignoring me.
Yeah, it's happening to me too.
Ah! Okay.
Oh, of course. Okay. Just leave. It just kicked me out. Okay. Definitely my Wi-Fi. Okay.
All right, speak up if you need me to give you another minute to think. I see a lot of people on boards have gotten theirs.
What question are we on again?
The number 2 that I have on the screen right there, it's very similar to number 1. Sorry, hold on one sec. Alex is having a problem with the... There you go. Okay, anybody need a second?
Okay, I think I did mine completely wrong, but
Well, hey, you want to, hey, there, that is okay. You want to tell me, I'm trying to get this link to work for Alex. Why don't you tell me at the same time? So tell me your reasoning, and if you messed it up, it really doesn't matter. So tell me your messed up reasoning then. What did you do, and why do you think you did it?
okay, I just went back in my notebook when we were doing solving equation with rational. I don't know how to say that. Okay, and I did it the same way that way. So it would be n times x. Yeah, that's where I think I messed up.
Are we
Can I
talking?
problem again? I had to go get my dog back from outside.
Oh, yeah. Are you talking about, wait a second, Blake. Are you talking about problem number 1 or problem number 2?
Wait a second. Can you go back?
Yes. Hold on. I'll share my screen again here. Hold, please. Sorry, I was trying to set something up for Alex there. Present now. My screen. All right, so we're talking about problem number 2.
Oh, never mind.
Okay, well, let's just talk through it. Like, what do we think? So, what are you trying to isolate? Tell me what to isolate first.
You have to isolate the x.
Yes, exactly, because it says isolate for x, right? So I'm going to bring it down here where I got a little bit more space. So what exactly is hanging out there with the x that needs to go?
You have to divide the k by both sides.
So so I need to actually do division?
No, multiplication, my bad.
How come I have to do multiplication?
I don't know.
What does this fraction bar mean?
Division.
Division. And so we got to cancel out dividing by k. And the opposite of dividing by k is multiplying by k. So that's why
Multiply. Okay.
what we do to one side, we have to do to the other side. So that's going to cancel. I've got my x isolated like I need it to be now. So I'm just going to write this as a multiplication problem together. So WK divided by V.
I don't know where to go from there.
Well, is my x isolated?
Yes.
What was the whole point of doing this problem in the first place?
To get X isolated.
Is it isolated?
Yeah,
Do I have to do anything else?
probably not.
No, I don't. Because
Okay.
the X is isolated. All right. The next one, guys, I'm not gonna lie. This one's gonna stress you out.
Wait, I have a question
Oh.
with Sue.
Absolutely, yes, sir.
So then, why instead of doing like all that work as soon as we see the problem, why don't we just put K on the other side so we don't have to go through all the steps?
What do you mean? Why don't you do K on the other side?
So we know that K is gonna be canceled out since we want to get X on its own. So why don't we already, like from the beginning, just put WK and then X equals WKB? Why don't we just put that if we already know that K is gonna have to be canceled out?
Well, you could. I mean, and there are a lot of you guys actually that the more you have the more number sense you get, because you guys are like some of you guys could probably actually do that step in your head. That's exactly what you did. What I did is and what Blake did was explaining out loud why we're able to do that. Because there still has to be a reason for why you can just move the K up. Does that make sense? Like, so really, you could probably see that. And that's something that a lot of you guys who have way better number sense than I do, like you guys can probably like get that figured out without having to do, you know, like the extra like showing where it came from. But for now this one was pretty basic, right? Because you only had to do like one step. You think they're gonna stay that basic?
No.
No, where would be the fun in that, right? So, speaking of not staying basic, copy down number 3 and leave yourself a lot of room.
We're doing this on a whiteboard, right?
No, I want you to do this on paper now, actually. I'm using the whiteboard. I'm kind of like asking you some questions along the way.
Oh, well, I've been doing everything on the whiteboard.
Oh, that's okay. So do this one. Yeah, the whiteboard's going to be a little awkward for you, and I want you to have like a record, like something that's a little bit more permanent for this one. Because this one's going to be a little more complicated because you know we can't keep it easy, right? We're too smart for that. Okay, so I'm going to give you guys a second to write it down. And I do want you to keep the whiteboard, or you can keep answering stuff in the chat too if you feel comfortable doing that. Either way, okay? But I'm going to be asking you some little questions along the way as we work this one together. Is there anybody that I'm still waiting on to copy this down? Or can I go ahead and go on? And I'm going to rewrite it down here because, again, I don't like it where it's all smushed up there with the directions. All right, so first and foremost, what am I going to isolate? What is the variable that I want to get by itself? See some people telling me in the chat, thank you. Some people writing it.
I got it.
Okay, what am I trying to get by itself?
X.
Yep. Now, you're going to notice that there's something kind of special about this one because you don't just have one X, you have two X's now. Don't fear, my friends. We have some extra work we're going to have to do, but we can handle it. Okay, so we talked about a couple of big ideas when it comes to solving literal equations. Number 1, you've got to get the designated variable isolated. Big idea number 2, you have to use inverse or opposites so that you can get that variable isolated, and you have to keep your properties of equality, what you do to one side, you have to do to the other in mind. Now I'm going to add another big idea, okay? And that is this, which I want you to write down. If the designated variable is in the denominator. Where's the denominator of a fraction? Top or the bottom, folks? Bottom, thank you. Yep. So if you have the designated variable in the denominator, it can't be isolated, so you have to move it. And allow me to demonstrate and explain why. In order to have a denominator for a fraction, for it to be a fraction at all, if there's a denominator, you obviously have to have a numerator as well. So, because no matter what, I mean, you're never in your whole life gonna see a fraction that has a fraction bar and a denominator, but there's nothing on the top. So that means that if that x stays there in the denominator, there always has to be something up here, which means you can't ever get it isolated. So another big idea we've got to add, even though it doesn't matter typically, and again, that's what bugs you smart kids, is that you can do these in a lot of different orders. Like you don't necessarily have to approach your inverse operations in the same order that I do. However, this is what I'm going to call an exception to the rule. If your designated variable is in the denominator, you're not going to be able to achieve your goal of isolating it because there's always going to be something in the top. So your first step should probably be getting that x out of that denominator. So this is my question to you that I want you to put either in the chat or on your whiteboard. Right now, you are just taking a good, educated guess. So I've got to get that variable out of the denominator. I'm going to use an inverse operation. What could I possibly do in order to get that x out of the denominator? And you're just taking a guess. You're taking a decent guess that has some kind of reasoning to it. Don't tell me IDK, don't tell me you don't know. You're right, you might not know. But you've got enough knowledge upstairs to at least take a halfway decent guess. That x is in the denominator. You've got to do something inverse related to get it out of there. What might that be?
I have a question.
Yes, sir.
So when I did this, because I think I finished it, I got x divided by x plus y, and I don't know, like, can we do that? I got rid of the y, so I don't know what I did wrong.
No, you can't do that. We got to get rid of the x first. Yeah, I wouldn't try to work ahead on this one because you probably aren't going to know exactly what to do yet. So step one, I know that x is in the denominator, and I got to get it out of there. So I'm not gonna move on until I see everybody. If you don't want to announce your...
Wait, can't you divide both sides by x then?
I don't know, can you? Maybe. Until I see everybody put an educated guess on a board or in that chat, I am not moving on. And even if you're wrong, it does not matter. I literally haven't told you this yet. You're just taking a guess right now. All right, now I think I see between the whiteboard and the chat, I think I see an answer for everybody. Okay, so this fraction bar means division, right? It means that we're dividing by x. So you guys were on the right track with division. I'd say that's the overwhelming response that most of you guys gave me. Most of you guys said, oh, are we going to cancel it out by division? So your head's in the right place. So in the original problem, we already have dividing by x. So we have to do the inverse of dividing by x. So maybe we might want to reconsider. Y'all made a good guess. Ding, ding, ding. Now we're changing our minds. Yes, the inverse, there's already division there. You don't cancel out division with more division. You cancel out division with multiplication. So what does it look like to multiply both sides by x? Well, it pretty much looks like it does multiplying anything else by both sides. You put your little parentheses out here to the side, put your x there, and you know that you have to do it on both sides because of our properties of equality. So I'm going to color code. So I said we're going to cancel dividing by x with multiplication. And even though there are different ways you could approach these steps, you didn't necessarily have to start with getting the x out of the denominator, but I always start with that. And my reasoning for that is it's going to have to get out of there at some point. So since you know you need to get it out of there, you might as well start with that. And that's the move that's going to make it like the fewest steps. So you can't have something in a denominator that's isolated, so you got to get it out of there. And so look what happens when we multiply both sides by x. So this x and that x cancel each other out. That was the entire point of multiplying by x in the first place. So now we have x plus y. And then over on the other side, it's now turned into a big multiplication problem. X times z times m. So what part just about that first step, why we had to start there, if it's in the denominator, you gotta ditch it. Now keep in mind the important part here is, because some people get confused, the key word here is the designated variable is in the denominator. If like the y or the z or something like that was in the denominator, you don't necessarily have to do this, okay? Because you're not trying to isolate that. But because you've got to isolate the x, and it can't be isolated in the bottom, you got to get it out of there. So are we good at this point? I know this is the one that gives everybody a headache. All right, so my x is still not isolated, and now I'm going to address the elephant in the room, which is that you actually have two x's in this one. And we haven't had one like that before. You have two of the designated variable. Eventually, we're going to have to do a little mathematical magic so that we end up with just one x, because that, by definition, is isolation, right? So we can't have two x's if we're isolating the x. In order to do that magic that we're going to do in just a second, we need to do this. So I'm going to add, whoops. If you have two of the designated variable, which we do, get them to the same side. Right now, they're not on the same side, are they? You've got just a plain old x over on the right-hand side, and you've got your xzm over here on the left-hand side. In order to be able to do the mathematical magic that we're getting ready to do, we got to get those variables on the same side. Even though it doesn't matter which order you do it in, I personally feel like it makes sense to move the x over here, because you're going to have to isolate it away from that y eventually anyhow. So it makes sense to me to get rid of the x and move that x over to the other side. So here's my question that I want you to put in the chat, or I want you to put on the whiteboard. How am I going to get that x over to the other side? What operation will I perform in order to make that happen? Give me your best guess. So I see people saying cancel, and you're right. I agree with you. Be more specific. How am I going to cancel an X? Like what specifically is going to cancel out that X? Okay, now I got a couple people being more specific. Now let's see if they're right. Ding, ding, ding. What is the opposite of a positive X? Well, what's the opposite of a positive 3? Negative 3, right? Same deal for the variable. The opposite of X is a minus X. And in true properties of equality, what we do to one side, we must do to the other side. So these X's have now canceled, so that all I'm left with is the Y. What I do to one side, I have to do to the other. Now, listen loud and clear, folks, for what we need to do on this left-hand side. So the XZM is kind of like, it's all one unit, it's all one term. That means that you can't actually combine it with just a plain old X. One way to think about it is, now they're related to each other. Let's say that this X is a McDonald's cheeseburger and this is a Happy Meal that has a McDonald's cheeseburger in it. They're related, but they're not actually exactly the same item. So that means when you go to McDonald's, you don't combine it into one thing. You say, hey, I need a cheeseburger, please, and I need a cheeseburger Happy Meal. Two different things, even though they have an item in common. So you cannot combine these. So you're just gonna have to rewrite it as a separate subtraction problem. So it's X, Z, M minus X. So I'm going to pause here for a second and just ask if we've got, because I'm about to do the mind-blowing part that I know you guys are probably like, what? But I want to make sure we're good with these first couple of steps. We're almost done, I promise you.
Okay, I think I just confused myself. If you subtract the X, that makes no sense then.
Like, which part makes no sense?
If you subtract the X, there's not going to be an X.
Well, you can't subtract X from an XZM because they're not like terms.
Wait, so then if it says get X on its own, then why is Y on its own and not X? Why didn't we subtract Y?
Well,
Yeah.
because now I got to do this part because I have two X's, right? I need to combine them somehow, but right now, because they aren't like terms, I can't put an XZM and an X together. Remember, for like terms, they have to have exactly the same variables. This has an X with a Z and an M, and this one does not. So we have to do something special, and this is something none of you guys have well, you might have had a 7th grade math teacher or an 8th grade math teacher that was like super on the ball, but it's very rare that I meet any freshmen that know how to do this at first. Okay, how are we gonna, so we basically need to get these two X's, and we need to get them to become just one single X, but we can't combine them. So we are gonna do something called factoring. Has anybody ever heard that word? And like I said, I'm going to be shocked if any of you guys have. Oh, Cameron has. Okay. No, I'm pretty shocked. Most people, I don't hear that very often. Okay. Factoring is the big kid algebra 1 way of basically saying dividing, or the opposite of multiplying, or the opposite of distributive property. And I'm going to show you what I mean, okay? Just bear with me. So in distributive property, you take something that's sitting outside the parentheses and you distribute it inside, right? Factoring, you are doing the opposite. You're taking well, actually, sometimes it's more than 2 terms, and you're looking for what they have in common, x and an x, and you're actually, instead of distributing it, you're going to pull it out of there. So let me show you what that would look like. So you had an x times z times m. So if you factor, is what that's called, if you factor out the x, what do you have left over? You still have the z and you still have the m. If you had just a single solitary x right here, but you factor it out, you pull it out, you are going to have a -1. And I'm going to prove to you that it really is just another way of writing the same thing. Okay, so if I go backwards, so right now I have x times zm minus 1. If I go back and I re-multiply everything together, you get xzm minus x. So you're doing the opposite of distributive property. Instead of taking the outside number and multiplying it by everything inside to basically end up with this, you start with this and you're going to pull out the x. I know that part. That's the part that you guys are probably all like, what? Because that is probably brand new to you. Well, for most of you.
Wait, is that 1?
Yes, that is a 1. Because if we were to go back and multiply it together, do you agree with me that x times -1 would give you a negative x? So if we're doing the opposite, if we're pulling that x out of there, that's going to leave us with a 1. So the reason we had to do that is because we need one single x by itself. But we can't combine an xcm and an x. We can't combine them together because they're not like terms. So we have to change our approach. We have to do something called factoring, which is where we're going to take that x and literally pull it out of there. You're just doing the opposite of distributive. And then finally, oh my gosh, we can get to the last step because the x is sitting next to those parentheses, which we all know means multiplication, I'm sorry. So we're going to cancel out that multiplication, and we're going to do that by dividing. So we're going to cancel multiplying by zm minus 1. And we're going to do that with division. And again, what we do to one side, we have to do to the other. When all is said and done, now that we're going to cancel out that zm minus 1, you finally have your isolated x like you needed it to be. And it's over y over 2m minus 1. I know that was literally just doing the mostest. I do not want you to panic. No, we still don't have a president yet. Bro, we're not going to have a president for a long time. You think that is going to court? Oh, that's going to be in court forever. All right, so I know this was just doing a lot. For our grand finale for today, we are going to walk through together. So we just use this number 3 as an example to go by. We're not going to get to the class kick today, and that's totally fine. You obviously don't need to worry about turning that in right now or anything. You're all good. For the last couple minutes, that was number 3 the whole time. Yeah, this was all number 3. So hopefully you have those steps written down. We're going to look at number 5. I'm going to talk you through it. You guys tell me using the whiteboard and using the chat. All right, so looking at example number 3, which is very similar to this one. Based on the example we just did, tell me what you think. We're going to skip to number 5 because I want to do number 5 because it's more similar. What do you think might be the first thing you're going to do and tell me why you're gonna do it. So looking at the steps we wrote down for number 3, hopefully you have that written down. Look at number 5 and tell me what you think your first step might be. But the more important part is tell me why you think it'll be that step. So you don't need to use the touchscreen for the whiteboard. You could literally just type that little A that's at the top and you can type me out an answer, because this is more of an explanation kind of thing. What if you're wrong? The world's not going to explode. I'm not going to yell at you. I'm not going to come to your house and beat you up. Look at what we just did. Take a good, educated guess. What do you think you might do first? And again, more importantly, tell me why. I'm going to shut up for a minute and give you a chance to get that down. Either put it in the chat or put it on the whiteboard if you feel more comfortable doing that. Honey, I am good old-fashioned Western Kentucky redneck trash. I can fight. You don't want me to come to your house. Okay, I see several people taking guesses. I want everybody. It doesn't matter if you're wrong. I haven't been in a fight in a very long time, though. I'm now... Oh my gosh, please don't go home and like tell people that I like beat people up. Oh, you're already at home, duh. Well, don't tell anybody. All right, not everybody's giving me a guess. Y'all are too afraid to be wrong. I'm just going to go ahead and tell you, it is so normal for this particular activity, for this topic. You're going to be wrong a lot, and that is okay. Give me a step. What might be the first thing we're going to do? That'll probably have to be our grand finale for today. Now I'm seeing some answers. I know. I'm wrong all the time, though, and you know what? It doesn't bother me. Once you get to be my age, you're not gonna. And like especially now that you're in, honors algebra, you're gonna be wrong a lot, and it's fine. Like, it is so fine. I don't see everybody making a guess yet. I'm gonna sit here and be like really obnoxious and keep repeating myself, except that, yeah, I forgot you guys can actually mute me. In classroom, when I am obnoxious, people can't just mute me. Take a guess.
I would say divide.
So what would be your reasoning for that? Why do I want to get rid of division?
Because you want to get rid of one of the A's.
I do want to get rid of one of the A's. What's the issue with this A being down here?
Is that there's no symbol between K and A.
What happens if the designated variable is in the denominator? Can we ever get it isolated?
No.
Yeah, so it's got to get out of there. That's got to be the first thing we do. And I just realized it's 129. So I'm going to have to shut up for today. We will start off on Friday with working this particular one. Again, don't worry about the class kick. I know how hard this is. That is why you're going to do it with my supervision. Remember that you can come for support. You guys will have your own support session Friday after this. And call, text, email, remind, whatever you need to do to ask me your questions. And I'll be happy to help you in between now and then. I got the support session today at 2 o'clock, but I can't guarantee you I'll be able to help you. If you want to try to drop by in case not a lot of kids come today, you can, but I'm not promising anything.
So what do you want us to do about the homework today if we didn't do it yet?
Are you talking about the
Yeah, 'cause
literal
I'm so
equations?
confused on this. I don't even know where to start, sort of.
The Google form one?
Yeah.
Okay, we can do that because Friday is going to be all work day. So we can work on that one some on Friday too, or during the support session. Either one. That's fine.
Okay, I'll do it Friday.
Okay.
When are you gonna grade it though, so it doesn't go in as a bad grade for me?
I promise I will not put that one in yet.
Okay. All right. Thank you.
You're welcome.
Bye.
So what's the homework?
Well, your actual homework that you need to do outside of class between now and Tuesday, 'cause you've got a couple days to do it. You got a week to do it almost. Is this one right here? So it's consecutive integer practice, but I kind of like chunked it up so that it's not all a mix of all three together, just for you to practice doing each one. That's why. So it's 3 separate assignments, and that's why you have a whole week to do it. And there's review videos in there if you need that too.
I'm confused on the work from last week.
On the what?
Work from last week?
So which specific work from last week?
Literal equation.
Oh, that's what Isaiah was just asking me about. Since that's what we're working on right now. That's what this stuff is literal
So
equations.
You just want me to
So-
wait till Friday?
So you can, yeah, you're okay. I know that this particular topic is going to be time consuming, but I told Yariel though, what I'd really like is for you to at least attempt it. Like, remember I told you you're going to get your points no matter what, how many you get right. I really want you to like try. And most people that have,
I did try. It's just every time I got my answer, it wasn't even on there.
okay, well, why don't you upload me a picture of your work?
Okay.
So that I can take a look at it, and I'll be able to write on there and give you some feedback about where you're going wrong.
Okay.
That would definitely be the best route.
All right, I'll try to finish it.
Okay.
Wait, is class over?
Yeah.
Oh, well.
Class
All right.
is